Hello everyone. Today we're going to be reading through this section on introducing the effects of friction. We remember in our previous reading we were reading about the conversion of energy in a car crash or in any other sort of encounter. So now we're going to be talking about the effects of friction. So let's just read through and then I'll make some comments as we go. It is blowing snow and the roads and sidewalks are dangerously slippery. What measures can be taken to ensure safety for drivers and pedestrians? You have probably noticed that trucks out sprinkling sand or salt when the streets are particularly icy. After this lesson, you will be able to explain why this is done. This is particularly interesting for Manitoba because in some provinces, like in Ontario, they put out a lot of salt on the road, and that's mostly for a chemical reason. The salt causes the ice on the road to melt. But in Manitoba, we often do sprinkling of sand because it's much colder than the other provinces. And so our ice is usually going to be there all winter long. But if we sprinkle sand on top, then the sand can get sprinkled, can become embedded in that ice, and it can increase the friction of the ground. So this sprinkled sand will increase the friction. This is the force that is going to stop motion in many cases. Essentially, any case where there are two surfaces in contact and there's motion between those surfaces, there is also going to be an effect of friction. Surface conditions. When you push off of a skateboard, you will roll down the sidewalk quickly at first, but then slow and eventually stop. The same event will occur if you stop pedaling your bike and coast, or remove your foot from the car's gas pedal. The first law of motion tells us that a moving object will continue to move until it encounters an opposing force. So there must be a force that's applied to your vehicle, and it is a case of unbalanced forces in this case. You'll have friction opposing a force of motion, a force from the motion of the object. One of the forces opposing motion is called friction. Friction occurs whenever two surfaces slide against and grip one another. This is due to some interactions between the materials. The amount of friction encountered depends on what the surfaces are made of, what the textures the surfaces have, the amount of force pressing the two surfaces together, and any substance that is in between the surfaces, like oils and glues. Those change the texture of the surfaces in contact. So perhaps you've noticed that the rate at which your skateboard or bicycle slows down varies depending on where you ride. You might coast for a long while on smooth concrete, but on rough gravel or on gooey mud you stop more abruptly. The amount of friction you encounter depends on the surface that you are in contact. Some surfaces stick and grip more tightly than others. And so this is an important concept because we have these four factors. So what the surface is made of. So for example, comparing, say, a concrete surface versus a surface of ice. You have one surface that's made of the material that they're made out of is very different. Ice has the ability to melt at a very low temperature, so that melting of the ice actually increases the slipperiness of the ice. So when a person's skate is on the ice, partially the reason that the skate slides is that the friction of the skate on the ice actually creates a little layer of water that the skate can slide around on top of. And so that's one of the factors that's important to ice being very slippery. But also you can remove some of the texture on ice with say a Zamboni, so that can smooth the ice out and get rid of any texture, and that will make the ice even more slippery because there'll be a lack of friction, a lack of texture on the surface. So of course, if you have a piece of ice that has sort of bumps like this, then the path of motion that the skate is going to go on is going to be be variable, and that'll create multiple sort of forces at every time the skate comes into contact with these different bumps and lumps on the ice. The amount of force pressing between the two surfaces together is also important. So if you have a large, a large hockey player on your ice, this is my hockey player. I've obviously drawn lots of hockey players in my time, not really. They have like big pants, okay, and they've got their skates. I don't know why I went with that kind of drawing, okay. So you've got your big hockey player, or you have a figure skater who is probably a lot lighter on their skates. The figure skater will probably be capable of reaching some coasting for a lot longer. So a figure skater can do those fancy spin moves because they're usually lighter, and they are able to glide for long periods of time without putting any extra force in, because the amount of friction slowing them down is less. Here, the weight of the hockey player will increase their force, so they have more force pushing down, and that increases the amount of force between the two surfaces, so the hockey player will have higher friction. So friction will be greater than the friction. Say hockey. Friction. Figure skater. Okay. All right, so friction and movement. Let's return to our dilemma of the icy sidewalks. As you walk on dry pavement, the friction between your feet and the pavement allows you to walk without slipping and falling over. When the sidewalk is covered in ice, the friction is significantly reduced, so that when you push off with your feet, there is less force opposing the motion. As a result, your feet slip and you might even fall over. So we're thinking about that shoe on the ground here, and when your foot tries to land on the ground, and in this guy's case here, you can see the foot is moving forward. So he's probably trying to place his foot down on the ground, and when his foot is still moving forward, but the ice does not oppose his motion. It has very minimal force backwards. On concrete, this force would be high. The frictional force would oppose it, and his foot would stop moving immediately when he hits the ground. But in ice, there's less force backwards, there's less frictional force, and so the foot will be able to overcome that force, and it will continue to move, and the foot will slip up, and he'll fall on his back there. Okay, and so as a result, your feet slip and you might even fall over. By sprinkling sand on the ice, we are adding some traction. Traction's another word for friction here, to the surface, so that once again, friction between your feet and there's friction between the feet and the ground. The same event applies on a street with cars. If we add sand, there will be more friction. This will allow for more controlled motion. What are some other examples of conditions that can affect friction and motion on roads? Well, we also have examples like your tires, right? So if you look at a sports tire, a winter tire versus a summer tire, then I'm just going to sort of draw a half circle here. Let's see if I can draw one of those. Okay, that wasn't quite what I wanted. Let's draw another circle. So if we have a tire, if we have the summer tires, I have some all-season tires. And typically an all-season tire looks kind of like it will be sort of this on the outside, and there's kind of these lines that kind of go like this. And all along the tire, something looks like that. But on the winter tire, you'll notice a much thicker tread, and this is increasing the texture. Sometimes there'll be even like little sort of hatches like this. And in other provinces, provinces or in the States, they'll even use tire chains. That was a really common way of getting extra traction. So these are your winter tires. Winter tires. And so these have increased friction, increased texture, which equals more friction. Now, one of the problems with making winter tires have more friction is that they usually use a softer rubber. So that softer rubber in the summer or in the early months of the even in early spring, that softer rubber can actually melt a little easier, and it can actually cause these to have some little microscopic bit of fluid there in between the tires. And of course, fluids between your two surfaces typically increase or decrease the friction. So winter tires actually have worse braking distance in the hotter summer months. And so that's why you need to change your tires if you happen to use two different types of tires, like in the summer and winter tire situation. So why is there more friction for a heavy object on a surface than for a lighter one? So let's think about that for really briefly. We've kind of discussed this in our hockey example above, but let's think about the heavy truck here versus a little car. One of the factors we said is the force between. So one of the factors of friction is the force between objects. So if both of these cars have the same amount of forward momentum, then that would imply that one car is probably moving slower than the other, since momentum is based on mass. This car here, this truck here, is going to have a very high mass, and so that means it will have a very large force downwards. This is the gravitational force, versus this car here, which is smaller in mass, so it has a smaller gravitational force. So the gravitational force is going to be greater for the truck, so that will be proportional to the frictional force. And by proportional, what I mean is that the greater the pull down on the car, the greater the pull between the two surfaces, right? This is the same pull that's affecting the tires, and of course equal on opposite pairs. So you're going to get equal and opposite pairs. Here, we're going to have a little tiny arrows here with equal and opposite pairs, one being the friction, one related to friction, one related to the pull downwards, or what we call a normal force and a gravitational force. And so in this way, we're going to have the larger the truck, the greater the frictional force, because the greater the gravitational force. And a greater gravitational force means that there is a greater squeeze on that connection between the surface between the tires and the surface of the floor of the ground. The friction between the two surfaces. So once you take this into account, the different types of surfaces will have different effects, different relationships in this proportionality. So what we use is something called a frictional constant. Measuring friction. The friction between two surfaces can be expressed as a decimal called the frictional constant. The closer the constant is to 0, the greater the friction. Several constants are listed in the following table. A rubber tire on dry pavement has a frictional constant of 0.06. So that's pretty good. That's very close to 0. If you compare that to wet concrete, so after a rain, the number is 0.10. And if you add snow or ice, and there should be a movement of the dot here, the dot is in the wrong spot. It should be right here. And so if you can fix that in your books, I would really appreciate it. If you could erase that, that would be perfect. So whereas snow and ice would be closer to 0.15. So, that's about half as slippery. So this is more slippery. More slippery. Now in this case, we have rubber tires on these three items. Because the surface texture is important to determining friction, these numbers will change with every single surface that you put on there. So if it's a rubber tire, if it's a plastic, a plastic wheel on your skateboard, or if you're rolling a metal, something metal down the street, a metal barrel or something, each one of those will have a different frictional constant. So the frictional constant depends on the type of materials in contact. So even a rubber tire, this is probably a very generic, we could actually modify these values by changing the tire type. So if you use a winter tire versus a summer tire, those would have effects on this frictional constant. Now this is a constant, and it is a sort of, it's an empirical constant, I believe, so it does not have units attached to it. Okay, in our next lesson, we'll talk about braking distance and how it relates to this frictional constant, but after this video, you should understand that friction is based on these four factors that are described here: what the surface is made of, so the nature of the surface, the texture of the surface, the force between the surfaces, and any substance between those surfaces. So of course we use oils and glues and things like that to even increase or decrease the surface tension, the surface friction even more. And also that the combination of these two materials and where they press on each other creates what is known as a frictional constant. And that frictional constant can be used in the future to calculate how much friction is affecting our objects. All right, have a great day, and we'll talk to you in the next video.